Thank you very much, everybody. Last panel of the conference. We're talking about AI today. With me, I have Anton. It's a sort of minimum viable panel because for very, very good reasons, Emilio could not attend today. So what we did is we took a sample of his voice and some photographs, and we put them into an AI, and we made robot Emilio, who will be presenting remotely. Actually, it's the real one. Or is it? We'll find out.
Well, I actually thought about doing that.
Now, the structure of what we're doing today is, first of all, Anton's going to be presenting some of his research and also talking about his interest in AI. Emilio is going to be doing the same. They'll take about 20 or 25 minutes each to do that. I have some questions. I hope you have some questions as well. So that's not too complicated. Anton, first of all, for you, your research on using Gen AI for economic research.
Thank you so much, Tim. May I also ask you for a cup of water?
Yes.
Great. So yeah, when I first wrote this paper, the term generative AI wasn't even really around yet. So the first version of the paper was just large language models and economic research. But now we all call this generative AI. And what I want to do with you, I want to share my general thinking about this latest generation of AI models with you. And then their applications for economic research, which in my perspective are really plentiful, and they can already make you significantly more productive. So I hope that this next year, this upcoming year, we will all be continuing to do research at a pace of 1.25 or 1.5 as what we're used to, thanks to the miraculous abilities of generative AI. So let me jump right into the slides. So first I want to emphasize, I think Emilio will give us a little bit of a broader framing of the progress in AI over the decades. But just from a pure perspective of use cases in economics, we are really in a new paradigm. The old paradigm of deep learning in the 2010s was incredibly powerful, and I think many of us have already employed deep learning tools as mainly statistical techniques or for optimization routines in our research in the previous decade. But in the 2010s, there was still always this category difference between human intelligence and artificial intelligence. And in some ways, I mean, we are of course still different, right? But in some ways, this category difference is fading away a little bit. And now we are in the 2020s in this new paradigm of foundation models, which underlie generative AI systems like ChatGPT, and they suddenly feel qualitatively different. So we are used to computers being not very creative, being highly deterministic and predictable, not making mistakes. And suddenly when we deal with these language models, everything is turned upside down. They can suddenly be creative. They make lots of mistakes. We call them hallucinations, right? They are no longer predictable or deterministic because of this massive parallel computation that's going on. The leading large language models are actually inherently stochastic. And it's impossible to replicate results, even if we set, for example, the temperature parameter that is supposed to govern that to 0. And what I want to suggest, so again, I want to very clearly state they are not human, right? But maybe the reason that they have acquired these kind of general capabilities is that we are coming close to the complexity of human brains when we look at the complexity of leading large language or vision language models nowadays. And of course, the leading category, and that's really what I will mostly focus on in my talk today, are large language models like ChatGPT. Google has just released a new system called Gemini, which beats GPT-4, and then there are others like Claude 2, Llama 2, and so on. So what is this all driven by? I guess for us economists, that's one of the crucial questions. Well, on the one hand, there is Moore's law, right? Computing capacity doubling every 2 years or something like that. But you know, honestly, that's nothing compared to the pace of progress in foundation models. What has been happening with foundation models is that the amount of computational power, or compute as they call it in Silicon Valley, has doubled every 6 months for the leading systems. So it means quadrupled every year. I mean, we're economists, you can do the compounding yourself, growing by a factor of 1,000 every 5 years. And this rapid progress is behind the sudden recent capabilities of large language models. Now, I guess reading the news, we are all used to reading from these kind of two opposing camps talking about generative AI. There's this one camp that says, oh, these are just dumb stochastic parrots. It's advanced autocomplete, and they emphasize all the limitations. And then there's this other camp that really hypes these systems and says, well, they are almost human-level AI already, and that camp emphasizes all the capabilities and usually engages in a fair amount of fear-mongering as well. Well, the truth is, I think it's really easy to both over and also underestimate these systems, and it's dangerous to do so. And we over and underestimate them because they function just so differently from our human brains and our human intelligence, and that makes it hard to relate to them. So my claim in the paper I'm presenting is not that they are conscious or anything like that. It's just that they are already highly useful for conducting economic research. And that's really what I want to focus on throughout the remainder of my presentation. So a little bit about the background, which is helpful for thinking about the use of these systems. So the training of these modern foundation models occurs via several steps, but the first and most important step is the so-called pre-training. That's when these systems are fed vast amounts of data, like all the texts they can scoop up on the internet and in the books of the world, and nowadays even from all the YouTube videos that Google possesses. And the training proceeds via a process called self-supervised learning, where the system is given the beginning of a text sequence and asked to complete it. So technically, they are actually advanced autocomplete. But you know, it turns out, in order to complete any given text in the universe of what humanity has ever written successfully, you actually need to develop a model of how the world works. You need to develop an internal representation of the world, or let's call it a world model. So when these systems are pre-trained, the best way for them to optimally predict how sentences are going to continue is to develop this representation of the world that tells them if they see the sky is blank, the most likely continuation is blue, or maybe today rainy, I'm not sure. And then based on this internal world model, these systems can complete all kinds of requests like what we see nowadays in ChatGPT or Bard or whatever system you're using. And the interesting thing is all kinds of capabilities have emerged from this self-supervised training, and it is capabilities that people were surprised about. So the people who created GPT-3, for example, they did not expect that it would suddenly be able to translate. But it turns out during the training process, the system managed to somehow abstract from words to deeper meanings and concepts. And now, if you tell it dog or chien or hund or whatever, it recognizes this is the same thing because it operates at a more abstract level. And yeah, whenever we draw on large language models, we essentially draw on these internal world models that modern foundation models have developed. I should say the cutting edge right now is to add more and more modalities to the pure text capabilities. So for example, to add vision and language models, or audio, video, and so on. And in addition, and this is interesting again from an economic automation perspective, there has also been a lot of recent progress on models for robots that are not called large language models, but large behavior models, where they essentially, just like language models, break down the sequence of language into individual syllables or tokens, as it is called. These large behavior models for robots break down real-world interactions, like let's say me waving this arm, into the individual muscle movements that are behind it, and that teach these robots to essentially become general-purpose machines. So that's the cutting edge right now. But now let me return to economics. And I have two main messages that I would love for you to take away and that I will try to convince you on over the next 10 minutes. First, so why should you start using large language models? First, a growing number of empirical research shows that there are really large productivity benefits for all cognitive workers across many fields, whether that is coding or writing or working as a consultant, or I guess in my paper, working as an economist. And the second reason is that the current generation of language models is not something static, but they are progressing really rapidly. So it's a good idea to start working with them now so that you can benefit from the advances of the next generation. There's a little bit of a learning curve, right? And yeah, a small PS here at the bottom of the slide. If you're not using the most cutting-edge systems right now, which would be GPT-4, which is available through OpenAI, or Gemini, which is not quite available from Google, but it will be available early next year, then you're wasting your time. So if you do this, use the cutting-edge systems, otherwise they're just not very powerful. Maybe one kind of quick piece of advice on prompts, and now I will engage in this dangerous act of anthropomorphizing a little bit again. No, I don't want to anthropomorphize, but a really good model for how to interact with these language models is to treat them like an undergraduate RA who doesn't really know very much about your research, but who is kind of pretty smart in a general sense, and very eager to help to the point of even making up stuff because it really wants to produce text for you. So that's how language models work, roughly speaking. But one of the problems is they completely lack the context of what you're doing. So if you want good results, what you need to do is you need to provide context, you need to iterate, so oftentimes I enter something, and then I tell it, no, move it a little bit into this direction, make it less hypey, make it more sober, more like me, I don't know. And then sometimes you also just need to be patient and try a few things. But over time, I think if you pick the right use cases, and I'm listing a whole bunch here in the paper, I'll promise you that if you invest 1 hour of your time trying out these systems, you'll get back more than 1 hour of productivity benefits. So the payoff period is pretty quick. Yeah, there are a whole bunch of limitations and risks and so on. I guess just like what you would do with the output from an undergraduate whom you don't really know, just check everything they do very carefully. That's the best summary. In the paper, I categorize the current capabilities of generative AI models into 6 different buckets, which I kind of found useful as a model for thinking about them. And I provide a total of, I think, something like 30 use cases that are spread across these buckets. Now, in my presentation today, I obviously don't want to go through all 30, and I guess, half a year ago, it was fun to kind of look at what ChatGPT writes in real time in front of you. But since the latest upgrade, it's so fast that you can't really read it in real time anyways, and it's no longer fun. So let me just give you a very high-level overview. The 6 buckets are, first of all, ideation and feedback. These language models are already quite powerful and useful for ideation purposes. Their bread and butter, of course, is writing. I'll say some things about background research. There are some things they're useful for, but some things that they're really terrible for because of their tendency to hallucinate. They are incredibly powerful for coding, and one of the reasons for that is because the labs that develop these systems are themselves using them for their own coding purposes, right? So GPT-5 is probably written to like an extent of 90% by GPT-4, and only the remaining 10% are actual humans who are writing code. They have become very powerful just in the last 4 or 5 months for data analysis, and increasingly they can even do a little bit of math. But I'll show you both use cases and mistakes in that domain. So yeah, the paper that underlies this, and it's not the kind of paper that you want to read, but it's more like a paper that you want to thumb through and see like, oh yeah, I have already tried this, I could try this too, oh, I should try this. And if there are any use cases that you think are promising and that I'm not listing, please tell me about them, because this is actually a living paper. I have to submit an update every 6 months to the Journal of Economic Literature, and they're going to put that on the website to replace the old version, because we decided it's such a fast-moving field that it doesn't make sense to just have a record that is set in stone forever. All right, so this is the whole list of examples, but let me jump over that. How do I think about the process of ideation and feedback? I put that first because I believe that's one of these domains where these large language models really differ fundamentally from the previous generation of AI. And I've listed here 4 use cases. Let me just start with an example. Here, if I could actually read what it's saying. I asked GPT-4, can you brainstorm 20 channels through which AI may increase inequality? And since it tends to write a whole paragraph about everything, I wrote, limit your response to 10 words for each point so that it fits into the journal, right? And it immediately listed, like within 10 seconds, 20 different channels. And of course, they're not path-breaking. GPT-4 is not human-level intelligence, right? But the sheer quantity of channels that it lists creates its own form of quality. And sometimes if there are like 20 things to pick from, even though I have thought quite some time about this topic, there were 1 or 2 that I actually hadn't quite thought about and that made perfect sense. And it's kind of the volume of idea generation that makes language models so useful for ideation. They can also, need to click in here, they can also tell you the benefits of and disadvantages of working on different research topics. So here I ask it, what are the pros and cons of working on the economics of artificial general intelligence, which is human-level intelligence? And I think it did a pretty decent job. Here in the 3rd example, I asked it for suggestions to improve the working paper version of this paper that I'm presenting right now. And they were all good suggestions. So this is a paper that does not use any high-level math, right? It's a purely methodological paper. And for something like that, language models are actually really good. Since I wanted it to process a full paper, I used Claude 2, which is a competitor of OpenAI, and they had a longer context window at the time I was doing this. And it came up with pretty good pros and cons, like things that I really experience in my daily life. And hold on. So then I started to become a little bit bolder, and I asked Claude too, well, can you write a referee report of this paper for the Journal of Economic Literature? And it did write a referee report. The comments were actually slightly less insightful than the ones listed here, but still the three main comments actually did have, I would say, a significant amount of overlap with what the referees also suggested. And so that means, and I want to make sure, if you even think, if you even start thinking about this, make sure that you follow, all the legal requirements of confidentiality and so on when you do refereeing. And of course, make sure that you add your human secret sauce. But sometimes for a first draft, this is really not bad. So I think we are going to move increasingly into a world where the refereeing process is going to incorporate large language models. I will jump over other brainstorming things. Let me turn to writing. Language models were, of course, designed for writing text, and that's why they are really good at this. They can do things like synthesize bullet points. This is a quick example that I just want to flash. They can correct mistakes. So if you're writing in English and English is not your first language, they are amazing at fixing every problem in your written language. I'm telling all my job market candidates, you have to run this through ChatGPT. And then they can even explain the corrections that they made. They can also give you kind of stylistic advice. Here I asked ChatGPT to give me feedback on the abstract of the paper, and it was pretty brutal. It says it was not clear enough. I used too much passive voice. There is a lack of specificity. There is some redundancy and so on. The kind of feedback that you rarely get from humans because we are too polite to each other. Can you rewrite it to correct these shortcomings? And yeah, of course it could rewrite it. So I incorporated some of these changes in the final version of the abstract. And then I oftentimes use ChatGPT to do brainstorming for catchy titles, and it's quite useful. And after I have finished the paper, I ask it to write a bunch of tweets that advertise the paper. And again, this is, something like summarization where you don't need the deepest understanding. So language models are really good at that. And honestly, I would probably just not post about my papers on Twitter because it's too much work for me otherwise. But using language models, we can all do this now. Maybe the CEPR could do this, like for all the papers that are coming out as working papers, to generate automatic tweets.
Yeah, thanks for the suggestion. Okay, yeah.
Now let's turn to one of the categories where it's not quite as good at, and that's background research. So if you ask, so there are some things where the language model is decent at, which is summarizing text. Let's say you want a quick gist of a particular paper. You can upload the paper and you can ask it, what should I pay most attention to beyond what's described in the abstract? Or what is most surprising about this paper? And oftentimes you will actually get pretty useful insights from doing that. However, if you ask it, can you write a literature review on, let's say, the use of AI in economics, I almost guarantee you that it's going to make up references that don't exist, because that's just how language models work. It's as if you ask an undergraduate who has never learned about the kind of process of scientific research and the requirements for factual citations. It's as if you ask them to write a literature review and you give them an example of prior literature reviews, and they see that there are people who are cited with names and years, and the undergraduate thinks like, I don't really know what that means, but let me write my literature review in the same way. Of course, you will get garbage out of that, right? And on the other hand, So as I mentioned already, they're good at summarizing. They're good at formatting references because that's just changing the structure of your text. They're also amazing at translating text. Probably the world's most advanced translator nowadays is GPT-4 or Gemini. And then let me turn to...
Last few minutes, Anton.
Okay, thank you. And then let me turn to one interesting example. So our undergraduate students are more and more using these tools to explain economic concepts to them. And so I played around a little bit with that. And oftentimes it's really amazing how well language models can explain simple economic things. And then I tried out the following prompt. What is the second theorem of welfare economics? And I did that in GPT 3.5, so the previous version, not the leading model. And it confidently asserted that the second theorem was the first theorem, and I had some follow-up, and it also insisted on the opposite. And there was just no way of getting GPT-3 to give the right answer. So this really illustrates that you need to be really careful using these systems. They are not factual repositories, but they're text writing machines right now. However, I should also emphasize they are getting better rapidly, and GPT-4 no longer makes this mistake. GPT-4 explains everything correctly in the context of welfare theorems. All right, we already covered coding a little bit. If you do code as part of your work, these language models, they are really amazing, and I think that's where we really see the largest productivity gains right now. So there's a study by GitHub that says people are more than 100% more productive in coding, and it takes all the boring tasks off your hands and lets you focus on the thinking part. So here I asked it to simulate the Solo model, and it just wrote the code from scratch and simulated it but let me just jump over that. It can also translate between programming languages. It can debug your code. Sometimes if you just copy-paste your error message, it can tell you what's wrong and how to fix it. And yeah, since the summer, GPT-4 has a plugin, an extension called Advanced Data Analysis that also allows you to create figures. So this is like a simple representation of stock market data, to perform calculations on it, like return calculations. For data analysis, it is extremely powerful, helping you format data, helping you rate data according to different categories. Here I'm rating FOMC statements into dovish or hawkish, and it's pretty good at that, and so on. Yeah, in math, which is the last bucket of capabilities that I will cover, GPT-4 can already help you to kind of write down models and start with some tentative derivations. I would say it's okay for use in advanced undergraduate problem sets and maybe even in working on the solution of advanced undergraduate problem sets. And sometimes maybe you can use it a little bit in your own research, but in math it's not great yet. So here I asked it to write down the optimization problem of a consumer with CES preferences. Then I asked it to solve it. Then I asked it to derive the demand functions, and it did everything correctly except it omitted the term alpha over 1 minus alpha, which I guess is something that we so regularly encounter when our undergraduate students do these types of problems, right? And GPT-4 does just the same thing. But aside from this mistake, everything was right. And when I pointed out the mistake, it conducted the derivation correctly. It can explain models. Here it just pasted math and asked it, can you explain what this is doing? And it says, yes, this is the Ramsey-Cass-Koopmans model, and explained every step of it. And yeah, this is essentially my demo, so let me just wrap it up. What are the short-term lessons? Right now, these systems are already very useful assistants and tutors, and they allow us to automate certain microtasks. And what's the economic response to that? Well, we should focus on our comparative advantage. We let these systems generate content, and we evaluate them, guide them, provide feedback, and so on. And that will make us complementary, and that will make us a lot more productive. In the medium term, I think there's no doubt that they will become better and better. The only question is how much better, and I will leave that conversation for our panel afterwards. But they will be adapted to lots of use cases. They will become better in math. That's something that the labs are working on really hard. And our role will diminish in many things, just like we no longer spend our time doing the tasks that calculators perform. And humans used to spend a lot of time on that in the past. And maybe we will also have some deflating experiences as the areas of work that are uniquely human will diminish. And then in the long term, the bitter lesson of progress in AI, that the advance of computing power makes AI better at everything, may eventually apply to us humans. But so this is my conclusion slide now. The good news is that these rapid advances raise lots of really interesting new substantive questions for us economists, including questions such as what will these rapid advances in automation imply for technological progress and growth, for labor markets, for education, for developing countries, and ultimately always for social welfare. And you see there are dots, I leave those dots. Emilio has a much longer list to fill in here from his perspective. And I guess the good thing is, as of right now, our human brains, especially when augmented by AI, are still the best technology around to answer all these important new questions. Thank you.
Thank you very much. Thank you very much, Anton. Imagine a world in which you never have to spend time formatting references ever again.
That's the world we already live in.
That is the world that you could be living in, yeah. Thank you very much for that. Emilio, yes, excellent. So Emilio's research into this is sort of complementary to what you do, Anton. So Emilio, let's hear from you.
Yes, so let me share my screen.
Yep, that's working.
For you? Hello. Okay, so thank you very much, guys, from having me there and setting up this video feed. I really appreciated it. Let me sort of complement what Anton just said by going a little bit back. I went digging for my slides. I teach an economics of AI course, and the first thing that I do every year is I try to define what AI is. And believe it or not, these kind of slides, they don't age well. So every year I have to revise, my even the definition of AI. So this is the kind of world that we're living in. And so let me give you my, kind of the first kind of official definition that we had. So on what is AI came, the first one that I found in policy circles was given by the Commission in the proposal for the AI Act in 2021. Okay, and so back then, AI was really thought about as a system that is basically software that is some statistical tool, is some technique that is that can be listed, and that's basically generating outputs or decisions that they influence the environment that they interact with. Okay, and then if you go into the annex and you ask, okay, what are these techniques? There was this kind of clear list. It's machine learning that includes supervised and unsupervised learning and reinforcement learning, using a wide variety of methods, including deep learning. That was kind of comforting to me, and as someone that wants to study the economics of AI, because at least I know what the object of the study is, right? And there seemed to be kind of agreement also in the broader circle of scholars interested in studying AI. That's kind of a first good definition. Now, you know that this has been in the news. It's been a political agreement. So this act has been changing over the years, trying to reflect the recent technological developments. And so in the latest draft, you know, the definition shifted. Now we're really kind of putting emphasis on these systems that operate in somewhat of an autonomous way. Okay, so we're kind of giving up on defining AI by the tools that power AI, and we're more thinking about the system at large and what it does. Okay. Now, if I think about what the definition is of AI, or better, what the views are of artificial intelligence in the academic literature and in our field in particular, I would say that broadly speaking, there are three views. Okay, one thinks of AI as something akin to a cognitive machine, superhuman. These are mostly like philosophical questions about what these machines are or can be in the future. Then there is some, a large body of research which is really defining AI as automation, okay, something that can automate tasks that were previously performed by humans. And then the one I always prefer, this is the body of the one I've been working in better, is a body of papers that thinks of AI as just statistical tools to make predictions and then decisions. Okay, so this is what is called, this is what we refer to when we think about narrow AI. Okay, now for me, if I have to give you my take on what AI is, I always thought of AI as simple software tools that are useful to cheaply, and I underline cheaply, crack dynamic decision problems under uncertainty. So you get solutions. You get solutions to problems. This problem to hard problems. I mean, these solutions are not going to be perfect, but they're good enough. Okay, given how costly they are. Now, AI is basically about making choices and then predicting the consequences of these choices going forward. Okay? And of course, if you know what the consequences of these choices going forward are, then the kind of choice part is really minor. Okay. Now, predictions are really key in the sense that these tools, they need data, right, to predict good choices in a context, and they can be classified basically depending on whether data is used as an input or whether they generate their own data. Okay, so data as an input means that these tools are basically learning, if you want, from others' experience. So this is like unsupervised and supervised learning are good examples of that. But the most sophisticated tools, they actually generate their own data. Okay, so these are the tools that play with things. They given some control variable, they kind of play with this control variable, and then they try to figure out what that control does, both to some kind of reward that they get, and then also to how that control is changing the environment, and of course the relevant variables in the environment which matter for the decision at hand. And these are slightly more sophisticated in the sense that they do two jobs at once. Okay, so on the one hand, they have to distill some policy from some data, or they have to distill some knowledge from some data, but they also have at the same time generate in some efficient way these data. Okay, now why are we talking so much about AI these days? Well, let me also give you my 2 cents on this kind of new development linked to the emergence or the deployment of this generative AI tool. Okay, so at first, since I've been thinking about these issues for more years than these tools have been around, I wasn't impressed. I thought, well, this is just hype. I mean, here we're really looking at prediction machines, as Anton was saying. So these are basically statistical tools that are trying to predict, the next word in a chain of words. So they cannot understand context or meaning, or they cannot reason. So this is, they're basically taught as stochastic parrots. Okay, so they do say things that sound like they understand, but they really don't. They cannot be creative in the sense that basically what they're doing is, they're generating videos or images by doing convex combinations of things that they've been exposed to during in the training phase. So in a way, these are just copycats. There is no creativity there, and they cannot improve on their own in the sense that they always going to need data, and so data is the important bit here. So data is the source of knowledge, and that's kind of an input to these systems. Okay, but then I have to admit, I had to change my mind over the years. I guess like everybody else that's been thinking about what these tools actually are. So first of all, this is of course the kind of debatable, but there is a sense in which we can think of these tools as being creative, okay? And they do generate, based on their knowledge, new content, okay? They do generate something which is not out there. And then, if you want, that's really fascinating because for two reasons. So first of all, because a few years back, I remember we were discussing what would be the comparative advantage of humans versus AI, and one of the things that always came up in these discussions was creativity, right? So there's no way that these tools can be creative. So for instance, our job is secure because there's lots of this kind of lots of creativity in what we do, right? But that doesn't, so this kind of generative AI tools seem to point in a different direction, and now this kind of opens up also a set of other interesting questions which have to do whether if this is actually creative, then you might be able to patent, right, some output of these tools, or to obtain copyrights. And I guess this is kind of a debate that we haven't had yet, but that we should. We could sort of use what we learned in kind of more than 100 years, thinking about what is it that makes a new innovation, what's a patent really. There is this idea coming from this case at the end of the 18th century, which kind of defined an innovation as something that contains a spark of genius, right? So you're not just doing a convex combination of two existing things, but there is a spark of genius. And then I think we should have this discussion of whether is there any spark of genius in AI. They can understand context and meaning, or at least there are some prominent scholars that think that these generative AI tools can understand context and meaning. For instance, Geoffrey Hinton, which is considered the godfather of AI, is a Turing Award winner, has been working at Google on BARN for 10 years. He's both a computer scientist and a cognitive psychologist, has been going around recently basically trying to make the point that predicting the next world in a long concatenation of words is equivalent or presumes some kind of understanding. And so the kind of discussion that we haven't had there is, how do you kind of devise tests that would allow us to think about how intelligent these systems are? And then as it turns out, the latest generations of these tools, they can improve on their own for the very simple reason that now we are unleashing them in the wild, in the sense that for instance, think about large language models. Now they can improve themselves just by using feedback from humans. They can improve themselves by using adversarial techniques, or they can improve themselves by just going on the internet and fetching more data. Okay, so for those of you who are familiar with ChatGPT-4, now you can ask ChatGPT-4 to go on the internet and kind of acquire some knowledge, right? And then distill it for you, right? So again, I think generative AI is really different, and so deserves our fullest attention. Okay, so let me move on to kind of what I think are so going back to the impact of artificial intelligence on the economy, let me give you what I think, my take on what I think are the key macro issues, okay? Now, the first issue has to do with the industry itself, okay? So first of all, the investment and the kind of research that is done in this area is vastly made in the private sector. Okay, so the public sector has been spending just a tiny fraction of their, its budget on AI, and the industry investment are basically dwarfing the public ones, and I guess we should expect more of these in the years to come. The industry is hiding more and more of the PhDs that are coming up out of these top program. Research faculty has been hired. I spent a year in 2022 at Berkeley and at the Simons Institute for the Theory of Computing, and I guess virtually everyone there was coming from computer science, spent some time in the industry, and everybody there kind of agreed that, contrary to what happens in economics, the research frontier is well represented, okay, in industry as opposed to academia. Okay. And so this is also reflected in the output of this research, in the sense that the industry is kind of increasingly dwarfing both the public sector and academia in terms of output. So you could measure this in many ways. So this shows you the computing power usage in image classification models, academia compared to the industry. This is typically measured in number of parameters, how large these models are. And of course, I guess, you're well aware now that the biggest AI models come from this handful of firms. Okay, that's another problem. Three more key issues in the industry have to do, of course, with concentration. So the idea is that there are huge economies of scale and scope in creating these systems. Okay, it's easy if you're say working on supervised learning to kind of expand into neighboring areas by just using your workforce. AI is an essential input. It's something we've been talking about. So this idea that now think about all those downstream products that are trying to integrate AI capabilities, and think about the fact that this kind of these firms are basically a bottleneck to access this kind of what seems a must-have feature for your product. Another key issue has to do with the direction of innovation. Okay, so the idea is that these firms who are driving the innovative effort, of course, they're doing this by trying to enhance their profitability. Of course, that's good. That's what they have to do. But then some scholars have pointed out that there is maybe an excessive incentive to invest in technologies that are meant to substitute for labor. Okay, so there is this debate between, say, trying to innovate in labor replacing technologies as opposed to technologies that augment or complement the labor force. A related debate has to do, is what Joshua Gantz, Jay Agarwal, and Avi Goldfarb has been, and more generally, the NBR program on the economics of AI has been thinking about this kind of stepwise process in which AI, the firms first go for the low-hanging fruits, and this is kind of mostly automation. So they think about how to use the technology to replace things that they're already doing. But then I guess we should expect later on this direction to change as the kind of systems or as the kind of institutions or as the architecture of firms changes to accommodate this new technology. And then another issue has to do with the fact that we live in a world in which research, development, and deployment of this technology is much faster than the public policies. Okay, so in a way, we're flying blind. Okay, by the time we reach any political agreement on what to do to regulate and tail, okay, these technologies, the technology is already evolved, and we have to start from scratch. And so maybe we'll talk more about policy later on. So why do we economists need to care and should care even more? Well, for two reasons. And first of all, there's lots of economics in AI, in the sense that those who develop AI tools, they do so, first of all, with the objective of unleashing them in strategic settings. And so the strategic reasoning and ways to cope with the strategic reasoning is embedded in these tools. And second, because economics can help, in a way, train and develop better algorithms by designing, in turn, strategic environments in which these tools are trained. And then, of course, the economics of AI, which is thinking about AI as a production input and thinking about consequences of diffusing these tools in the economy and in marketplaces and society at large. There are a plethora of applications that are already being deployed in various markets. These are, wonderful wonders of AI, and I myself have been thinking about a subset of these. So my own research has been focusing on recommender systems and pricing algorithms. Now, the kind of problems we've been thinking about when it comes to applications, but we've been thinking about exploitative and manipulative behavior. So there's this debate on price discrimination, this idea that these tools might engage in self-preferencing, might basically violate privacy, infringe copyrights, might extort user data. We've been talking about statistical discrimination and algorithmic bias. So this idea that, of course, these algorithms might use covariates of race, gender, and religion as an input in their process. We're talking about this idea that they might affect the policy, the public discourse by, say, locking us into echo chambers. We've been talking about social media as being an example of that. Other issues have to do with this idea that these tools are actually designed to persuade agents to make choices, and then again, is that abusive or not? And then, of course, again, these other issues like algorithmic collusion and the issue of big data. Okay, so just to conclude, let me kind of, drawing from my own work, make this very concrete, like thinking about how is it possible to study kind of vivid market application of AI? What are the relevant questions, and what can we do going forward? Okay, so in one line of research, I've been thinking about AI algorithms. Okay, so these are tools that sellers have been increasingly using in online marketplaces. So if you want to picture this, think about shopping on Amazon. Right. So the idea, so there is evidence that most of the merchants that price on Amazon are using some form of automation. It's actually very easy to automate prices on Amazon. So let me show you how easy it is. So for instance, if you're a vendor on, say, Amazon Seller Central, you could just go insert your credential, go on your dashboard, and then click on automate pricing and decide which rule you want to use. You could use a mechanical rule, or you could use a third-party algorithm to power your prices. And then what happens is, from that point onwards, you basically delegated your strategic choice to one of these algorithms. Okay. Now, of course, these algorithms, they're going to take over, they're going to observe market conditions and set prices. They're typically powered by reinforcement learning algos. So they're trying to maximize profits. They connect to the platform via APIs. So Amazon makes it actually very easy for firms to design these pricing algorithms because they think this automation is kind of source of value. And then what they do is they try to figure out what's the best price for your good and try to figure out how to react to the competitors that you're facing in all of those markets. Okay. Now in this environment, so it's just the kind of research questions that you could ask is, well, are these AI pricing tools a good or a bad development? Are these tools pro or anti-competitive? Now, it could be that on the one hand, that if these tools are very good at learning to compete, it might be that indeed by incorporating more information which is relevant for prices, they will increase the allocative efficiency of markets, they will reduce prices, and this could be a potential good outcome. Or we could consider the possibility that, say, these tools might find ways to increase prices, or say that these tools actually end up raising prices. Now, if they do, then there is another question, an interesting question, which I think, well, if you observe that, whenever that the diffusion of these tools is linked to higher prices, this could be because of one of two things, either because maybe these tools may actually fail to learn to compete. After all, competing effectively in these settings is basically coping with highly strategic environments. It's not clear whether this kind of algorithms are fit for this purpose, or you could ask whether they could learn to pollute, right? And then how can you tell? Can you devise tests to be able to kind of tackle this question? Another line of research that I've been working on for the past 4 years or so is on recommender systems. So these are algorithms that we use repeatedly every day, or that we are exposed to repeatedly every day. Okay, so these are basically the algorithms that decide what we see on our newsfeed when we go on Facebook, Twitter, or whatever. These are the algorithms that decide what we see on Netflix on the homepage when we log in. These are the algorithms that decide how to rank products on Amazon search result pages. So basically, one way of thinking about these tools is that they provide personalized prominence. Okay, so they use some data and they try to predict. So they use some data and they try to predict among a set of items what are the items that would actually engage us the most. Okay, and they do this in a collaborative fashion, in the sense that they try to also use data from similar users to try to figure that out. Okay. Now, of course, these algorithms they shape consumption choices, right? I guess we all agree that the way products are displayed on search result pages is going to affect what we end up buying, and the way. So those kind of playlists that we have at Spotify will end up decide what we listen to, and so on and so forth. And then if you think that they shape consumption choices, then kind of a natural question is, how do they affect these choices? But an even more interesting question is, what about, say, the producers of these products, right? So what about their incentives? I mean, we're basically moving from a world in which firms, merchants were catering to consumers, to a world in which merchants, understanding that their strategic choices are going to be mediated by an algorithm, they try to think about, okay, so what would please the algorithm? What would make it more likely that my product will come up on top? Okay, what kind of quality do I have to provide? What kind of variety do I have to provide? What kind of price do I have to fix, right? And so on and so forth. So I guess the idea, the underlying the overarching goal of this research project is to really understand how these algorithms change the anatomy of demand. And basically what we show is that, so we basically contrast a world with and without recommender systems, and we show that this kind of demand, the anatomy of demand changes considerably. And then this, of course, has profound implications on firms' incentives to lower prices, market outcomes, and so on and so forth. Now, of course,
Emilio, this has a last couple of minutes, Emilio.
Oh yes, no, I'm almost done. So I just want to make one other point on this, which is that, one way of thinking about this kind of exercise is the following. So recommender systems, you could think of them as tools which are meant to recover preferences from some data. Okay? So the idea of these tools is to basically exploit correlations in consumer tastes, right? So the idea is that if someone like me, whatever that means, purchased something and liked it, or bought something and liked it, or clicked, or retweeted something that he liked, then I will be more likely to like that content as well. But I remember when I first encountered these tools, I thought, okay, but so they're basically estimating preferences, or they claim that they're estimating preferences, and then are they the right tool to do so, right? So we as economists can say a lot on whether these kind of algos or tools or machines, if you want, that are kind of affecting and interacting with agents in marketplaces are actually fit to do the job that they're supposed to do. And basically what we show in this paper is that, at least for the particular recommender systems that we study, for that particular tool in a specific setting, they are unfit to do so, in the sense that, for instance, they tend to amplify similarities, right? So because my, say, estimated utility is going to be an average of the utility, say, of similar users, then this will lead to what we call homogenization of taste tests. And homogenization of taste tests, estimated taste tests, can be a source of concentration, right? So and then it could be, in a way, one foundation for a finding that market outcomes are more concentrated than they should if those recommendations were made in the best possible way. Okay, so let me stop here, and then maybe we'll discuss more later.
Yeah, thank you very much, Emilio. Yeah. I know I should be better than this, but I'm still blown away by the fact that Anton told me we've created an AI that can understand a state error message. Come on, that's funny. Okay, now, I've got lots to discuss, but I think it's probably better if you have a chance to ask some questions, because you probably have questions that would be the same ones that I would ask. So we've got lots of hands at the back there, and then there's two more. Are we doing it in microphone, or are we shouting it out? Because I'm worried that Emilio might be able to. Yes, thank you very much. Could we go to the back first? Back is yours. Yeah. Thanks very much.
I'd like to hear what you think is the likelihood of homogenization. Emilio talked about homogenization, but I'm interested in homogenization in intellectual endeavors. Intellectual endeavors have to be on guard against common wisdom, and I'm a little bit scared about what kind of abstracts and referee reports we're going to get now. And of course, there's more broadly a concern about innovative and other kind of intellectual activities. I'd like to hear about that.
Okay, good one. Homogenization. Could you pass the microphone over there while we answer this? Yeah, Anton, do you want to go?
Sure. Yeah, I guess some journals have already been so foresightful to give you only one referee report. But I guess if everybody's using the same ChatGPT, you may get like 4 identical referee reports in the future. But more seriously, I do think that that's actually a very serious concern. So the people who wrote the paper that coined the term foundation models in 2021 listed this potential for increasing homogenization as one of the main things that they're worried about. And it follows right from the economics of this all. As Emilio already observed, there's this very strong tendency towards natural monopoly, because you need to spend 100 million, soon 500 million, 1 billion to train a model like this. And then they're all trained on very similar data sets, so they're all going to look similar as it is. And yes, there is a tendency towards homogenization, which is a collective action problem ultimately. So I think what I can imagine very easily is that we'll drift into a world where these tools help each one of us individually be more creative, but our collective creativity may suffer a little bit. And you know, there are ways of counteracting that. If I use them for creativity, I try to always kind of spice things up a little bit by first uploading a paper of mine that gives it one particular point of view, or telling it to argue from one specific corner. So we can do stuff to counteract this, but the overall problem is there.
Thank you. Emilio, do you have a point of view?
Oh, yeah, so yes, let me just add that you know, one of the issues as these tools diffuse has to do with the fact that you know, they are now learning by basically from a body of language, let's call it like that, which is human generated, right? And so, and another thing that we've been talking about is if you know, we more and more output comes from these machines, then that also means that more and more of the input that these machines use to generate more output will come from machines themselves. And so what are the consequences of that? And that's kind of a concrete question that hasn't been tackled at all. And you know, I would love to understand more on, and then you know, maybe think about potential fixes to this problem if we think it's a problem at all.
There's a little cluster of questions there. Yeah.
Since I have the microphone, I'll take that privilege. So macroeconomists like Anton and I learned from Bob Lucas 50 years ago that sophisticated prediction algorithms can break down when those predictions influence the environment that it's predicting. We call it the Lucas critique. And what do we know about the possibility of the Lucas critique coming and damaging us in this space?
We're taking the whole.
Yep.
We're taking.
Yeah, we'll do the cluster.
I was interested in the aggregate productivity implications, which I know Anton's thought about. I mean, on the one hand, it seems like, you know, we've heard in this talk, it makes us more productive in many ways. It can also make bad actors, loosely defined, more productive. Emilio talked about, you know, anti-competitive, you know, potential risks of anti-competitive behavior, or kind of amplifying market imperfections. You could think about, you know, filing environmental objections to a wind farm that is necessary for the green transition, or cybercrime and things like that. So how do we balance those two?
Excellent. And the third in the cluster. Sure. There we go.
Just also related to a couple of the other questions, but specifically on this Lucas critique idea, I think we already see a little bit of evidence of this, the admission by OpenAI about a week ago of the existence of a winter break hypothesis where ChatGPT has gotten lazy over the Thanksgiving break, and it was so persistent that OpenAI had to make a public statement. I mean, you see it actually if you try to use data analytics, and you actually have to insist multiple times. It says, oh, you can do it yourself, here's a recipe, instead of actually doing it and generating it for you. I thought that's quite interesting, but it also gives you some hope that maybe we won't achieve super AGI that will take over the world because they're going to imitate us anyway. But anyway, and then I know that the EU AI Act was mentioned briefly, but in the context of this, and especially on the concentration question, do you see, I mean, it clearly went further than the US executive order. Is it, are we handicapping Europe? Is that going to have global effects, regional effects? Is that going to offset concentration or make it worse? Thanks.
Okay, so we really do have to discuss that. So, yeah, Lucas critique, aggregate productivity, and the AI Act. Anton first. Pick any one of those, yeah.
Yeah, I love these questions. So my kind of version of the Lucas critique is that if you leave something out of your model, and in the case of Lucas, it was expectations, then you're gonna get wrong answers from your model if the left out parameters change. And I guess that's always been true, and it's also true for oversimplistic machine learning models. And I think as systems like, let's say, GPT-4, Gemini, manage to build more complete models of the world, they're incorporating more and more of these left-out factors. So I'm not too concerned about that being a major handicap for progress. On the question of aggregate productivity, I published a piece on that with Eric Brynjolfsson and Martin Bailey, and our view is we are extremely bullish on the productivity implications of generative AI. So if I can unpack that a little bit, we think just from rolling out the current generation of tools, if we make no further progress, we will actually see a productivity boost over the next couple of years of easily 10% across advanced economies. And that's just because so many workers are cognitive workers, and if all of us become a little bit more productive, that really has macro implications. And then cognitive work also contributes to the process of innovation and rolling out new products, and that process will be accelerated. So we predict that will give an additional productivity boost, and our projection is the next 20 years will have at least twice as much productivity growth as the previous 20 years. And that's not even factoring in the new models that are certainly going to come out and are going to be very capable. And overall, I think in the next few years, the positive effects will almost certainly outweigh the negative effects, the empowerment of bad actors. But this is something where I personally think we really should focus some significant regulation. The EU AI Act has done so a little bit, but has left out, due to quite a lot of lobbying from within Europe, has left out anybody who makes their model publicly available without safeguards. I don't know if that was the wisest choice, but I guess this is all a work in progress.
Emilio.
So let me first comment on the Lucas critique. So just by telling you my own experience with this. So I've been playing with some of these tools now for many years, and it's true. They optimize against a fixed environment, and they're very good at that. Okay, so they're very good at figuring out how to crack a problem in a fixed environment. Now, of course, if this environment is populated by economic agents, then that means that the economic agents will react to the algorithm's choices, and then that would basically be perceived by the algorithm as a change in the environment. Okay, so now these algorithms are basically operating in an environment that, from their own point of view, are changing just because the underlying agent are adjusting their behavior to adapt, and so then you typically end up in loops. Okay, so the algo optimizes, and then the agents optimize, and then the algo optimize, and then the agents optimize. And some of these loops are never ending, which I thought is quite interesting, because that also means that sometimes we have to figure out, not just the resting point of this kind of learning processes, not just, but also maybe what this kind of, if you want, orbits, if you want. And non-stationary systems. And so I'm a bit, you know, these systems are not really designed, but given my interactions, okay, with the CS people, these systems are not, most of these systems, especially those already in marketplaces, are not designed to deal with in multi-agent settings, okay? But there is some hope in the sense that at the frontier of research, you know, the most sophisticated ones are trying to incorporate these aspects and to provide algorithms that achieve a goal that are robust, okay, to that kind of critique. About the AI Act, well, I mean, the AI Act is really consumer protection. At least that's the way I like to think about it. So the idea is that, you know, they're devising rules for placing on the market, for putting into service the use of AI systems. That's literally Article 1. Okay. Now I like to make an analogy with the system that we have in place to make sure that the drugs, okay, that we introduce in markets are safe. Now, you know, like algorithms, you know, drugs, if they, you know, if they might cause a lot of harm, okay? And so that's why we go through all the trouble of having agencies and setting up RCTs and clinical trials and so on and so forth. So we're basically going slowly in that direction where we're trying to, you know, tell firms that they, you know, we're updating the liability standards. We're trying to tell them that they're responsible if something goes wrong. We're trying to equip them with auditing systems and so on and so forth. Is Europe handicapping itself by doing so? I'm not sure. Okay, I guess again they're protecting consumers, and nothing prevents a European company, say, to have a subsidiary somewhere else. Say if that's the kind of concern you have in mind, and say to develop algorithms which have not been, say, green flagged by whatever European authority you might have in mind down the road. And then, you know, again, no firm will be able to deploy those algorithms in Europe. I don't know. I'm kind of I'm really trying to think hard about why we should consider measures that are meant to protect the final consumers as something that could hamper, okay, the innovation or the development of these tools down the road. But clearly I have in mind, and that goes back to what I've said before, I have in mind an industry which is very concentrated. So I have in mind, say, a European champion, which is kind of battling with 2 or 3 American champions and a Chinese champion, and all these firms are active simultaneously in all these markets.
Thanks very much. We'll do one more question. Has to be quick answers because the conference has to end at some point. And so we did have, yes, down here. Yep, down, as far as Elisa.
So first of all, thank you so much to the CEPR committee for putting this amazing conference together. And I think the 2 keynotes on financing the transition AI are also the biggest topics in the world. So you mentioned that, Anton, fantastic presentation, that AI in both sort of sometimes underperforms relative to humans, but in many ways overperforms. And then in the end of your presentation, you mentioned that humans' brains are augmented by AI, and that's actually perhaps the best technology we have. And indeed, in my view, actually AI offers us extended intelligence, also perhaps to timely tackle some of the biggest problems that we have in the world, including climate change, because we have maybe 6 years of carbon budget left. So my question for you, and I think you already touched upon this a little bit, is how much do you think ultimately our extended intelligence via AI can help us sort of increase our rate of innovation also in the sciences to make a difference in this world?
Okay, rate of innovation. Good one to finish off with.
Well, I guess the declared goal of the founders of DeepMind was to solve intelligence and then use intelligence to solve everything else, including global warming, political conflict, who knows what. Now, when they first pronounced that in 2014 or so, that seemed utterly naive, but now we may already be a little bit closer to it. So I personally think that there's a wide range of uncertainty about where this technology is going in the coming years. But I would no longer rule it out that it actually surpasses our human minds, our human intelligent capabilities across the board. That would be called artificial general intelligence. And what I advocate in a number of my recent writings is that we collectively, but also I guess individually, because this is going to affect each and every one of us, we should start to prepare, like in the spirit of scenario analysis, for the possibility that these AI systems are just going to become smarter than us. And that would have really fundamental implications. It would certainly speed up innovation quite significantly. It carries a lot of risks with it, as we discussed before. And it might be one of the most significant challenges that we've ever encountered to make sure that these highly advanced systems are still going to continue to do our bidding. So I want to encourage each and every one of you, this is my closing statement now, think about what these rapid advances in AI will imply for your specific field and area of expertise, because I think there are many really interesting questions to be solved, whether that is climate finance or labor markets or macro or micro or who knows what. I think advanced AI is going to affect each and every one of the areas of economics quite significantly. Thank you.
Emilio, could you wrap us up, please? Hopefully with something a little bit less terrifying than what you just said.
Yeah, so I am on the positive side in the sense that I recognize the terrific potential of the technology, as I guess everybody else in this room, and it's crystal clear that this technology is going to create soon tensions on labor markets, on the income distribution issues, the financial stability, taxation, education. So this is going to transform society. But I believe that we're gonna learn how to harness this technology. We're gonna learn how to use it to augment our capabilities. And if you want, going back to policy measures, the AI Act is one little step in the right direction, in the sense that it's really thinking about controlled experimentation and testing to make sure that nothing goes wrong. And what I think we should be doing right now, given how far the industry is to double down. Okay, is to double down on regulation and take measures that ensure that our future will stay bright as I expect it to stay. Yeah, that's it. I don't know if that was positive enough for you.
Thanks very much. Yes, it was. We are out of time now. Thank you very much for your questions. Thanks very much for the presentations and for answering the questions. I mean, there's one thing that I want to say about this. I spend about half my time working with technology people, and we always think that what's going on in AI, what we know about what's going on in AI is right at the leading edge. But what is actually public now is sort of what they did 18 months ago. So that's something always to remember, that this is not some kind of static frame of reference, and this is what it does. And the second thing is, if you really want to catch up with what's in the AI Act, and you don't want to read the whole thing, you could always ask ChatGPT to do a one-page summary of it for you. Very useful indeed. Thank you very much. Thank you, Anton, and thank you, Emilio.
Thank you. Thank you.
Yeah. That's it. Yes. Thank you very much. We come to an end. Thank you very much. Thank you for being here. Hope you found it useful. Tell people what you found useful and they'll do more of it in the future.